Okay, guys, this problem has to do with specific heat and data that was collected in a lab. We're actually going to do a calorimetry lab where you're going to see this in action. But what it is the question's asking how much heat is needed to warm 250 grams of water, which is about 1 cup, from 22 degrees Celsius to near its boiling point, which is 98 degrees Celsius. And they give you the specific heat of water is 4.18 joules per grams degrees Celsius. So you're going to need to know the specific heat of water. It'll be given to you sometimes, but you definitely need to know that the specific heat of water is 4.18. What the specific heat is, it's the amount of energy required to raise 1 gram of a substance by 1 degree Celsius. Water has a relatively high specific heat capacity in comparison to other substances, and we'll learn about intermolecular attractions later and hydrogen bonding and why water's specific heat is a lot higher than some other substances, say like a metal like aluminum that only has a specific heat of 0.89 joules per grams degrees Celsius. So having said that, we have an equation that we need to use here, and it is our energy equation to calculate. It's Q equals M times C times delta T. To review what this means, Q is energy in joules. M stands for mass. C stands for specific heat capacity. And delta T is our change in temperature. Anytime you see that little delta sign, it means change. And delta T is calculated by taking the T final, so the final temperature, minus the T initial, which is the initial temperature. So it's always final temperature minus initial temperature will give you the delta T for a reaction. All right, so continuing on with this, now we need to figure out what they've given us. They ask us how much heat is needed to warm 250 grams. So we're going to be solving for Q, which is the energy in joules. And to do that, okay, sorry, had to fix my headphones there. Okay, so to do that, we are going to plug some numbers into our equation. We don't know what Q is. That's actually what we're solving for. And our mass that they gave us was 250 grams. Our specific heat of water is 4.18 joules per grams degrees Celsius. So it has 3 units, one on the numerator and 2 on the denominator. And then our last is our delta T. So let's calculate our delta T really quickly here. Our final temperature was 98. And our initial temperature was 22 degrees Celsius. So our overall delta T in this case is 76 degrees Celsius. So it's always the final temperature minus the initial. So this water was heated up, so it absorbed energy. So it makes sense that we have a positive delta T. And that just goes right here. So 76 degrees Celsius. You can leave it in Celsius, no need to convert to Kelvins because it's an overall temperature change. So if you converted it to Kelvins and then found the final minus the initial, you would find that it's still 76 Kelvins. It's the same overall temperature change. That's why it doesn't really make a difference. Now we just multiply these 3 things together. When we do that, you'll notice that the mass cancels, degrees Celsius will cancel, and we're going to be left with joules of energy, and that's what we want. And it ends up being 75.2, whoops, not 75.2, my bad. It's actually it's actually 79,000 joules. and it's fine to leave it in joules. Sometimes they'll convert it to kilojoules, but it's okay just to leave it in joules unless they specify otherwise. So to summarize what this all means is this is how much heat in joules, energy in joules, it would take to warm water and 250 grams of that water from room temperature to about its boiling point. So that's an endothermic process. That's why our Q is positive. So positive 79,000 indicates that our overall energy was actually added to the system for this process to occur.